Good evening, children. Good evening. I think online we have only Gayatri today. Good evening, Gayatri.
Good evening, ma'am.
Good evening. I've shared my screen.
Yes, ma'am. It's
Yeah,
visible.
very good. This is the first question for today's class. Give possible dimensions for length and breadth of the rectangle whose area is 9a squared plus 3a minus 8b minus 64b squared square units. So we are given this expression which represents the area of a rectangle. Now, supposing you're given that the area of a rectangle is 24 meters square. Okay, the area of a rectangle is 24 meters square. Now, if you're asked to give the possible dimensions, you will say if length is 12, breadth is 2. Good evening. If length is 12, breadth is 2. Or you will say if length is 6, breadth is 4. Or you will say if length is 3, breadth is 8. Understand? See, you can have even fractions and decimal values. We are just, like giving some examples involving integers or natural numbers. You can have decimal values also. Okay. So like this, length 12, breadth 2, or length 2, breadth 12, length 6, breadth 4, or length 4, breadth 6. So like this, you can give different combinations. Wherein the area of the rectangle is 24 meters square. So here, like you have a number, 24 meters squared. In the question here, it is an expression. It's an expression. So you have to factorize the expression. That's what we did here also. You know what? What did we do with 24? We factorized 24. 2 12s are. So if length is 2, breadth is 12. Or if length is 12, breadth is 2. What's another way of factorizing? 6 and 4. If this is the length, this is the breadth. Or if this is the length, this is the breadth. Other ways of factorizing, 24, 3 and 8. If this is the length, this is the breadth. So we actually factorized unknowingly. We didn't do it consciously. When area is 24 and you're asked to give possible values for length and breadth, you just do it like that. It just comes as if very naturally, right? You say 8 and 3, 6 and 4, 2 and 12. So what are you doing actually? You're factorizing 24. In the same way here, you have to factorize the given expression. So factorize can be done, or factorize has to be done depending on the expression given. So in this case, sometimes you can factorize by splitting the middle term. See, how to factorize depends on the expression given. Okay, so here we have an expression with 4 terms. We have an expression with 4 terms, of which these 2 terms are perfect squares. Observing the expression is very important. Okay, we have 4 terms. We have an expression with 4 terms, of which 2 terms are perfect squares. So what we do is we rearrange the terms. So we write 3a minus 8b, then plus 9a squared minus 64b squared. What we do? We are going to group 9a squared and 64b squared. So we're going to group 3a minus 8b. 3a minus 8b is one group, and 9a squared minus 64b squared is the other group. Now write this 3a minus 8b in the bracket like this, plus 9a squared minus 64b squared in another bracket. Now nothing can be done with this because it's already simple, 3a minus 8b. But this is of the form a squared minus b squared, 3a the whole square minus 8b the whole square, which can be written as 3a plus 8b into 3a minus 8b. Now, what is common? 3a minus 8b is common. Can you see this? This is common. 3a minus 8b is common. 3a minus 8b is common. So write out that common thing one. See, this is one expression. This is the second expression. This is the first expression. This is the second expression. in the first, so between these two expressions, this is common. This one is common. Write out that common factor here. Okay. So now this is common. So what do you write in place of that 1? Then this plus sign as it is. This one is outside common. So write the other one, 3a plus 8b. See, please use this idea. If you have a plus ab, what is common? A is common. A plus ab is nothing like, it's nothing but 1 into a plus a into b. A is 1 into a. A is 1 into a plus a into b. Now a is, open a bracket. A common, right? So in the bracket, you must write 1 plus b. 1 plus b. Do we get that? A, okay, supposing you have x plus xy. X means 1 into x. Now what's common? X is common. Open a bracket. X is common. So what should you write inside the bracket? 1 plus y. 1 plus y. In the same way here, 3a minus 8b. There's 1 here. Just imagine, just imagine a 1 there. So 3a minus 8b is common. So in the bracket, you'll have this 1 plus this connecting sign plus. This one is outside, common. So write this one, 3a plus b. Sorry, 3a plus 8b. Now this one as it is, open the bracket. So you have 1 plus 3a plus 8b. Open the bracket. Okay, that's it. We're done. You can stop here, or because I have 3a minus 8b here, no, I want to write this as 3a plus 8b plus 1. Just rearranging because the first bracket is 3a minus 8b. So in the second bracket, I write 3a plus 8b and then that plus 1. It is okay if you stop here also. So this will be factorized in this situation. But see, I told you, depending on the expression given, you may have to factorize by splitting the middle term, or you may have to use some formula. You may have to use some formula. So it depends on the expression given. So here, group these two terms and these two terms. And for these two terms, use the identity x square minus y square, which is x plus y into x minus y. And after that, this expression is common. Take out that common expression. And in the bracket, you would get 1 plus this one. You want to, no, do you want to go out and wait, or you want to wait here? All right, I finished them or I stopped somewhere in the middle. I don't know what I said. So I was telling you this is common, right? And then 1 plus, this is common, this is common. So this one. Then open the bracket. Write this one as it is, open the bracket here. So 1 plus 3a plus 8b. The answer ends here. But since this is 3a minus 8b, we write this as 3a plus 8b plus 1. So these are the two factors. So this expression is equal to 3a minus 8b, one factor, into the other factor, 3a plus 8b plus 1. This expression is equal to this factor into this factor. So if this factor is the length, the other factor is the breadth. Or if this factor is the length, then the other factor is the breadth. All right? Yeah, please write. Take down the question and write on the answer. Done, children?
Yes, ma'am.
No? Okay. Next question.
Excuse me, ma'am. Ma'am, just show the last slide, ma'am. I didn't complete it.
Okay.
Just 1 second, I'll take a screenshot.
Yeah.
Yes, ma'am.
Yeah. This is the next one, children. Sorry, I took you to a different question. This is the next one. Please try this one. You didn't get the two numbers, is it? I'll tell you how to do it. I'll tell you how to do it. All right. So now let's recall how to split the middle term. Okay. What is the sum, children? The sum is 13 and the product is 35 into 12. Minus 12. What is it? Minus 420. Okay, so take up the number 420 and perform the factorization method. So 2 210 times, 2 105 times, 3 35 times, 5 sevens are 7 ones are. All right. So 420. This is your rough work. So 420 is equal to 2 into 2 into 3 into 5 into 7. All right. Now, you should use all these numbers and make two numbers. You must use all these numbers 2, 2, 3, 5 and 7. You must use all these numbers and make only two numbers. Okay, so that the sum is 13. Forget the product. You will get the product because these are the factors of the product. Product you will get because 420 is equal to 2 into 2 into 3 into 5 into 7. Product you will get. You just have to, focus on getting the sum. Okay, so now let's try. So 2 2s are 4 and 5 7s are 35, 3s are 105. Now think like this, 4 and 105. When you add or subtract, can you get 13? No. So leave that. 4 and 105. You add, forget, they can have the same sign, different sign, whatever it is. With 4 and 105, you cannot get 13. So that combination will not help. Leave that. Then, so like this, we should try. 2 2s are 4, 4 3s are 12. 12 and 35. 12 and 35. 35 and 12, if you add, you'll get 47. And 35 and 12, when you subtract, you get 23. No, you're not getting 13. So leave it. Don't worry if it is plus 23 or minus 23, plus 47 or minus 47. We want the number 13. So 12 and 35 cannot give you 13. Then not possible. So maybe 3 to 6, 6 5 are 30 and 14. 2 3 are 6, 6 5 are 30, 30 and 2 7 are 14, 30 and 14. Okay, 30 and 14 will give us 16. 30 minus 14. 30 and 30 and 14 will give us 30 and 14 will give us 16 or 44, not 13. So like this, we should work different combinations. So the combination that will help us solve the situation is 2 2s are 4, 4 7s are 28. You can jump, not that you should multiply in the same order. Okay, so 2 2s are 4, 4 7s are 28 and 3 5s are 15. See, we have made use of all the numbers. You should not omit even one. Then you will not get the product. So 2 to the 4, 4 7 are 28 is one number and 3 5 are 15 is the other number. Now with 28 and 15, you can get 13. Now fix the signs. You need to get a negative product, but a positive sum. Positive sum. See, first thing is you'll have to subtract, no? So they should have different signs. How will you get, with 28 and 15, how will you get 13? By adding or subtracting? You'll have to subtract. So subtract means they should have, both the numbers should have opposite signs. One plus, the other minus. If it is adding, then they should have the same sign, either both minus or both plus. 28 and 15 can give us 13 only on subtracting. The difference is 13. So they should have opposite signs. And you see that the sum is positive. So the greater number should be positive, the smaller number negative. Only when you subtract 28 and 15, you can get 13 as the sum. Meaning here you're subtracting, but the sum is what we call it, no? Sum. If you want to get 13, you should subtract. Subtract means they should have opposite signs, one plus and one minus. And here the sum is positive, it's a positive 13. So that means the greater number should be positive. So plus 28 and minus 15. So the two numbers with the help of which you split the middle term are plus 28 and minus 15. So plus 28y minus 15y. Write this one and this one as it is. Split the middle term using these two numbers, correct? Then you'll have to group these two terms, these two terms. We know that, right? From there we know. Correct? Okay, maybe we can just do that. So what's common between these two terms? We understand this, children? The two numbers are plus 28 and minus 15. So plus 28y and minus 15y. We have split the middle term. Write the first term and the last term as it is. What is plus 28y minus 15y? Plus 13y. Now grouping. Group the first two terms and the last two terms. First two terms and the last two terms. What's common between 35 and 28? 7. Y square and y. Now 7y into 5y is 35y square. Then 7y into 4 is 28y. Then this minus sign as it is. This minus as it is. 15 and 12, 3 is common. Y is not common because here there's y, here there is no y. So 3 common. 3 into 5y, 15y, and 3 for the 12. Sign you know, children, plus into minus is minus. Then this 5y plus 4, write it once. 5y plus 4, write it once, and then 7y minus 3 in the other bracket. So these are the two factors of the expression for area. So if this is the length, this is the breadth. Or if this is the length, this is the breadth. All right? Please come. Yeah, what's your question? Louder, louder. Well, come here. Because it's unique. Only one set of numbers we have. Not get them. How is it 240, by the way? 210, no? That's a mistake. Okay. Peter? Yes. Okay.
Done, ma'am.
Very good. Yeah. Yeah, this is the next one. Give possible expressions for the dimensions of a cuboid whose volume is a plus b the whole cubed minus a minus b cubic units. Then a number. Give me an example or a situation. I don't understand your question. One second. No, it should not expand. No.
Choose multipliers. 3 minus 3. We can cancel the term.
Oh, you're saying this plus b and minus b. No, a plus b is it's a plus b the whole cube, right? So the no. So the power influence is here. So if you're cancelling this plus b and minus b,
when we expand the identity, we get that last term is a plus b over. We can take it by a minus by minus b. Minus a minus b. You can cancel that.
yeah, if you get this situation, then you can take minus common. Then it will be minus a minus into plus is minus b. Now if it is like, if you have this, yes, you can cancel. Like this you can cancel. You can. Okay. Not here. Completed. Factorize the expression. No, you should factorize a plus b the whole cubed. Okay, see. A plus b the whole cubed minus a minus b can be written as a plus b the whole cubed minus a minus into minus is minus into plus is minus b. Is this correct? Is this correct? Because minus a minus into plus is minus b. All right. Now, if you want, you can expand. You can write this as a plus b into a plus b the whole square. See, if you want. Otherwise, you understand that a plus b the whole cubed is what? A plus b into a plus b into a plus b. So, and this is a plus b. This is one expression. This is the other expression separated by a minus sign. So, between the two expressions, a plus b is common. Correct? So then what will you get in the first place here? A plus b the whole square, right? Because a plus b into a plus b the whole square is a plus b the whole cube. Then minus a plus b into 1 is a plus b, correct? A plus b is common. A plus b into a plus b the whole square. A plus b into a plus b the whole square is a plus b the whole cube. And a plus b into 1 is a plus b minus a plus b into 1 is a plus b. Now, this is like a difference of two squares, right? This is like a difference of two squares. Write this a plus b as it is. And this one is like a plus b the whole squared minus 1 squared. Yes or no? Yeah. So, that can be written as x squared minus y squared is x plus y into x minus y. This is your x squared. This is x squared. And this is y squared. So your x is a plus b. And your y is 1. X squared minus y squared is x plus y. A plus b plus 1. X minus y. A plus b minus 1. So now we've got 3 factors. So these are the 3 factors of the given expression. So if this is length, this is breadth, this is height. Or if this is length, this is breadth, this is height. Or if this is length, this is breadth, this is height. You can make so many combinations. If this is the length, this is the breadth, this is the height. That's what you have to write. All right? Sorry? I put 2 times. No, what is that? There's a cuboid. H. No, I haven't repeated anything. All the 4 are different combinations. In the first one, I'm saying if this is the length, this is the breadth, this is the height. The second one, if this is the length, this is the breadth, this can be the height. Third one, length, breadth, height. Fourth one, length, breadth, height. Which 2 are similar, you're saying? In the last one, you're saying what? இதுக்கு பதிலா பிரெட்டா அப்புறம் இது ஹெச் போடலாமே ஒன்றும் எப்படி வேணாலும் போடலாமே. You can take this also as the breadth and this as the height. Why? Any combination. All right. Completed?
Yes, ma'am.
Okay. Okay. So first we have to take out this minus sign common, and in the bracket minus into a is minus a. Please look at the board. Minus into a is minus a. Minus into plus minus b. Okay. Then a plus b is common. A plus b into a plus b the whole squared is a plus b the whole cube, minus a plus b into 1 is a plus b. Now here this is of the form x squared minus y squared. A plus b the whole squared minus 1 the whole squared. So x squared minus y squared is factorized as x plus y into x minus y. X, this is x plus y and x minus y. So now we have three factors, 1, 2, 3 factors, L, B, H, different combinations. That's the question. Give possible expressions for the dimensions of a cuboid. What are the dimensions of a cuboid? Length, breadth, and height. Length, breadth, height. So give possible expressions for the dimensions of a cuboid whose volume is given to you. Do this. No. So we have one thing right? Yes, Sanuvit, you have to. 1 and 20, right? No, that's not the first step. So in the expression, whenever there's something common, you'll have to first take out the common factor. We have understood that as the golden rule while factorizing. In the expression, when there is something common, how many terms are there in this expression? 3 terms. All the 3 terms have 2 and k in common. All the 3 terms have 2 and k in common. So take out the common factor. That's the first step. I'll present the answer slide now. Yeah. You got it? Yeah. What are the factors? 2k into correct. Correct. So you can see here 2k is common. Always take out the common factor. 2k is common, so you have this in the bracket. Now split the middle term and get the other factors. Very good. Is it the same as this answer? Very good. Yeah. Uh, 2ky square plus 6ky. No, 1 minute. You're writing 6ky as what? No, remember this rule. Because not that you should not do like this. Always remember, work using rules. Whenever there's something common, take with the common factor first. Don't work it like that. Take with the common factor. 2k is common, right? Take it out and then factor. Then you can factorize. Yeah. And then you write length, breadth, height. Correct? Possible dimensions are, and finish it. Possible dimensions. Children, please try this one. I'm just getting a call. This is the next one. Please try this.
Ma'am, can you please go to the previous slide, please?
Just give me 2 minutes. Some of them are writing this question. Let them finish this.
Excuse me, ma'am.
Yeah.
Ma'am, I'm having an appointment with doctor like 8:30, I guess, ma'am. Can I leave the meeting now?
Okay, Gayatri. Take care. Bye.
Thank you.
Yeah. So after this, children, the earlier answer, possible dimensions. Yeah, Shreya, you wanted the slide, right?
Yes, ma'am, but I've taken a screenshot now and I've also completed, ma'am.
Okay. Yeah. No, you can group it however you want. You want to group the first 3 terms, huh? Yeah, if you're able to factorize, yes. You're able to factorize like that? Okay, let's see. So group the first two terms and the last two terms. I think it's clear, right? Yeah. Last two terms, there's nothing common. That means one is common. Yeah, you have the answer completely. Very good. Great. Completed? Online children?
No, ma'am.
Okay.
Yes.
Okay. Okay. So please listen. So by now this part and this part is, like familiar and also I assume very clear. So we factorize and these are the three factors. And then you give possible dimensions like this, right? If this is the length, then this can be the breadth and this is the height and so on. Now, what is this verification? Verify the result. How do you verify? So this is the expression, right? For volume. Volume is equal to L into B into H, right? That is the product of these three factors is equal to this expression. The product of these three factors is equal to this expression. So that's what I've written here. That's what you see here. This expression is a product of these three factors or is a product of these three expressions, right? So now you will have to work the LHS and RHS separately. Take the left hand side, take the LHS, and when x is equal to 5, find the value of the LHS. This is what you get. Now take the RHS, this is the RHS, and find the value of the RHS also when x is equal to 5. Should get the same answer in both the cases. So LHS, RHS, you get the same answer. You're verified. Completed this one? Yeah. Okay.
Yes, ma'am.
Okay. So verifications about this volume is equal to, this is volume. Volume is equal to L into B into H. So this is the left hand side, this is the right hand side. Work the LHS when x is 5. Work the RHS when x is 5. Both the answers must be the same. Then you're verified. Everything on this. Okay. Yeah. Go through. You can help yourself. Complete this answer. I'll just come back, children. Please work this one. All right. So here we see that this expression x squared plus 7 is in two places, and this expression 2x minus 1 is also in two places. Okay, so we'll call this expression x squared plus 7 as A, and this expression 2x minus 1 as B. Or you can assign them to any other two variables, P and Q, whatever. So now rewrite the expression using A and B. Rewrite the expression using A and B. So this is 12, this is A, this is A. So 12A squared minus 8, this is A, and this is B, minus 8AB, minus 15, this one is B, so minus 15B squared. So 12A squared minus 8AB minus 15B squared. All right. Now factorize by splitting the middle term. What is the product? The product is 12 into minus 15. That is minus 180. And the sum is minus 8. Correct? The sum is minus 8. The product is minus 180. So the two factors are 10 and 18. 10 and 18. And signs minus plus. Okay. So plus 10 and minus 18 are the two numbers. 10 and 18. 10 into 18 is 180. And you know, plus 10 minus 18 is minus 8. Same procedure. 180, 290 times, 245 times, 3 15s, 3 5s, 5 1s. So 2 into 2 into 3 into 3 into 5. So 5 2s are 10 is one number. Excuse me. 5 2s are 10 is one number. And 2 3s are 6, 6 3s are 18 is the other number. இதே procedure எல்லாம் கண்டுபிடிக்கிறோம். 2 5s are 10 is one number. 2 3s are 6, 6 3s are 18 is the other number. And fix the signs so that you get minus 8 as a sum and minus 180 as a product. So this is minus 8 and minus 180. So when you split the middle term, what are the literal factors here? AB. AB. So you must write plus 10AB minus 18AB. Plus 10AB minus 18AB. Any order. You can write anything first. I've written minus 18AB and then 10AB. Any order. You can write this first and then this. That's fine. All right. Then group. First two terms, last two terms. Please group. And that gives you 2A minus 3B into 6A plus 5B. But A and B were not the variables given in the question. We introduced them. So put the original expressions back. In place of A and B, put the original expressions back. See, actually, this is the end of factorization. So something into something, finished. After this, meaning nothing can be done beyond this. But what is that you have to do? Because A and B were the variables introduced by you, right? So put the expressions back. What is A? X squared plus 7. What is A? X squared plus 7. So see this 2A, 2 into x squared plus 7 minus 3 into what is B? 2x minus 1, 2x minus 1. This in one bracket into 6A, 6 into x squared plus 7 plus 5B plus 5 into B is 2x minus 1. Now open the bracket, multiply. So 2 into x squared, 2x squared plus 14 minus 6x plus 3. 6x squared plus 42 plus 10x minus 5. Then you have 14 plus 3, 17. And 42 minus 5, 37. Now, you should see if you can factorize this further. That is, what's the product? 34. 34 is a product, right? And what's the sum? Minus 6. What's the product? 34. What's the sum? Minus 6. Now 34 is 2 into 17. There is no other, or 1 into 34. These are the only two combinations you have for 34. For 34 as product, we have only two combinations. 1 into 34 is 34 and 2 into 17 is 34 or 17 into 2. 3 into 4 into 5 into 6 into 7 into nothing. Now, will 2 and 17 give you 6 as a sum? No. 1 and 34? No. So this cannot be factorized further. I'm talking from our syllabus point of view. When I say cannot be factorized further, I don't literally mean that. Meaning you can, you cannot find, rational factors. We cannot find rational. So so keeping our syllabus in mind, you cannot factorize this further. Why? Because we are not finding the two numbers to split the middle term. Correct? We understand that? Because 34 is 217 times and 134 times. But neither of these two combinations can give you the sum as 6. With 2 and 17, you'll get what? 15 or 19. 7 and 2 will give you 15 or 19. What will 34 and 1 give you? 35 or 33. 6 we are not getting. So you cannot split the middle term. And here what's the product? 6 into 37. That's a product and the sum is 10. So here also this 37 is a prime number. 37 is a prime number and 6 is 2 into 3. So you can just look at that and guess. Now with this you cannot get sum as 10, right? Because 37 and 6 it is. 37 and 6 cannot give you 10. Or if you 37 into 2 is 74. 74 and 3 you're taking larger numbers. You cannot get 10 as a sum. 6 into 37, 6 is 2 into 3 into 37. Using these numbers, these three numbers, you'll have to make two numbers to get the sum as 10, which is not possible. Correct? So you cannot split the middle term. So this is the end of the answer. This is the end of the answer because you're not able to, this is quadratic, this is also quadratic. You want to split the middle term and factorize further. But no, we are not able to find the two numbers to split the middle term. So it ends here. This is the answer. Sometimes I'll give you another situation where you will be able to factorize it. Yeah, this one further. So this, we stop here because we are not able to factorize it any further. Is this over? Okay. Similar situation. See here. So here, a square minus 2a, a square minus 2a. So we'll call that as x and rewrite the expression. So it will be x square minus 23x plus 120. Okay. All right. I should actually write this one here. These two steps, no, should come here, children. One minute. No, let me not. These two steps, no, please put it here. That's all. That's all. Yeah, start working. Oh, not there. Sorry. I'm gonna split panniten in. You know what? Yeah. Done? Yeah. So here, like when you split the middle term and factorize, you get x minus 8 into x minus 15. So you'll have to put the expression back in place of x. X is what? A square minus 2a. Here also x is a square minus 2a. Now this is quadratic, this is also quadratic. Sum is minus 2 and the product is minus 8. You are able to split the middle term, minus 4 plus 2. The product is minus 8 and the sum is minus 2. Here also you are able to split the middle term. Minus 5 plus 3. Product is minus 15 and the sum is minus 2. So like this, if you can split the middle term, you should proceed. And finally, you see 4 factors. All right. Then, yeah. Completed, online students?
Yes, ma'am.
Okay. Yeah, work this one. Yeah. Online children, use the emoji, raise your hand. Only 3 today. Okay. Yarni, Shreya, and Harsha. Okay, good. All right. I'm not taking efforts to explain because I think now this is very basic for you. Yeah. Okay, next one. That is you. Completed? Okay. So here you have x squared minus y squared, which is x plus y into x minus y. Okay, so here we have x minus y, x plus y, and this can be written as x squared minus y squared, right? Okay, so this is the expression given, this is the expression given, and this can be written as x minus y the whole square minus 7, x squared minus y squared is x plus y into x minus y, and plus 12 into x plus y the whole square. So the only change is x squared minus y squared, we write it as x plus y and x minus y. Now we see that we have x minus y in two places and x plus y in two places. So let's call x minus y as a and x plus y as b, and rewrite this expression using a and b. So this is a squared minus 7 ab ab plus 12b squared. Split the middle term, and that will bring you till this step. Now here, what is a? X minus y, and what's b? X plus y. So carefully replace it. A is x minus y in a bracket minus 3 into b into x plus y. Use the brackets correctly and carefully. Similarly here, this is a minus 4 into b like this. Then open the bracket. Here also open the bracket by multiplying and releasing all the terms, and then simplify the like terms, simplify the like terms, and you have this. Actually, you can stop here. You can stop here. So I'll just tell you what is here in these two steps. You can stop here. Now, if you want to continue like this, see here, all the terms are negative. In the two brackets, all the terms are negative. All the terms are negative. What you do, you take out what's common. If nothing is common, take out minus 1. Okay, but here what's common? Minus 2 is common. Minus 2 is common. Take out minus 2 common. And then you have these two terms in the bracket. Here nothing is common. But just take out minus 1. You want to bring out that minus sign. Okay, so take out that minus. So minus 1. Okay, and see it's a multiplication here. Multiplication. See, 1 minute. One. Okay, so see it's like this is equal to minus 2 is common. So in the bracket, minus 2 into x is minus 2x, minus into minus is minus to plus is minus, and 2y, correct? Now, this is already a product here, right? So I'm just putting that multiplication. It's already a product there, you see. It's already a product here. So into. Now here between these two terms, there's nothing common. I'm forcibly taking out minus 1. See, multiplication, how we got is it's already multiplication. So that multiplication sign and minus 1 out. So it will be minus 1 is out, so it will be 3x plus 5y. Because minus 1 when you multiply with this minus 3x and minus 5y it will be. Now children, it's product everywhere. Minus 2 into x plus 2y into minus 1 into 3x plus 5y. It's minus 2 into x plus 2y into minus 1 into 3x plus 5y. So what is plus 2 into plus, sorry. What is minus 2 into minus 1 plus 2? That's what you see here. Minus 2 into minus 1 is plus 2. And then this x plus 2y and 3x plus 5. All right. Well, just tell me that last step. Minus 2x minus minus 2x minus 4y, then minus 3x minus 5y. So what did we do? Here minus 2 is common. So x minus into plus is minus, 2 2s are 4, y. It's already multiplication here. So into minus 1 is common, minus 1. So 3x minus into plus is minus 5y. Now minus 2 into minus 1 is plus 2 into this one, x plus 2y, into this one, 3x plus 5. All right? That's what we have there. Completed, all of you? Just putting you with a test paper now. One second, sorry, I'm just not able to decide on the presentation. Yeah. Just give the heading revision and try these questions. Revision. Heading revision, polynomials revision. Try this. Check if minus root of 2 by 3 is a 0 of f of y. Zero? Correct? Correct. It is a zero of the polynomial. So in place of y, you have to use minus root of 2 by 3. Minus into minus plus and square root of 2 by 3. If you square it, the result is 2 by 3. When you square root of 2 by 3, the result is 2 by 3 and minus into minus plus. So the answer is yes. That is the next one. Sorry, I didn't unmute. I started explaining. Okay, so here in this question, 0 and -1 are the two roots of this cubic polynomial. 2x cubed minus 3x squared plus ax plus b is a cubic polynomial. And we know a cubic polynomial has a maximum of 3 zeros. 2 zeros are given to you. 0 and -1 are the 2 zeros. And what is the, speciality of the 0? If you, when in the polynomial, in place of x, if you put that 0, the answer, the value of the polynomial will be 0. In this polynomial, in place of x, if you put 0, the answer you get will be 0. Again, in this polynomial, in place of x, if you put -1, the answer you will get 0. Because it's given that they are the zeros or the roots. That's what we have written here. F of 0 is 0. That means in f of x, in the place of x, if I put 0, the answer is 0. In f of x, in the place of x, if I put -1, the answer will be 0 because they are zeros or roots. So here when you work, you get b 0. Now here in the place of b, you put 0 and you're able to find the value of a. So a is equal to -5, b is equal to 0. All right. I'm looking for a particular question because that's important. Not finding that. Ah. Yeah, well, this important. Yeah, please work this one, children. Okay, I'll just break down the steps, so that you find it easier to understand. Please listen. X square minus 1 is a factor of this polynomial. X square minus 1 is a factor of this polynomial. You can see that this is a biquadratic polynomial. The degree is 4. It's a biquadratic polynomial. This one is quadratic. Okay. Given this, we need to show that a plus c plus e is equal to b plus t is equal to 0. Now, to use the factor theorem or the remainder theorem, we know that this one should be linear. Okay, this factor should be linear. If it's quadratic, break down and find the linear factors. So factorize x square minus 1. So before that, what do you see here? This polynomial is not named. So we give a name to that polynomial because it's convenient to work when you name the polynomial. So this polynomial, we are calling it p of x. The variable is x. So p of x. If the variable is y, p of y. So p of x is equal to the given polynomial. Always name it. Okay. That's the first step. Next, x square minus 1 is a factor of p of x. It's given. So x square minus 1 means x minus 1 into x plus 1. So these are the two factors of p of x. Okay. Now take the factors one by one. X minus 1 is a factor of p of x. Work with that. Okay, I'll tell you what we're working. And then x plus 1 is a factor of p of x. Work with that. So how do you work with x minus 1 as a factor of p of x? X minus 1 is equal to 0, x is equal to 1. So in the polynomial, in the place of x, if you put 1, the answer will be 0. Because it's a factor. What should you write here? I've told you. You should write the remainder here. And when you divide, what is x minus 1? It's a factor of p of x. So when you divide p of x by x minus 1, what will be the remainder? 0. I've always told you, when you get this x value, p of, in place of x, if you put 1, then the remainder is 0 because it's a factor. X minus 1 is a factor. Similarly, here x plus 1 is equal to 0, x is equal to minus 1. In p of x, in the place of x, if you put minus 1, p of minus 1, then the remainder is 0. Because you're dividing by a factor. So this place is reserved for the remainder. I've told you many times earlier. This place after the equal to sign is reserved for the remainder. So since x plus 1 is a factor, the remainder is 0. So you have the equations. P of 1 is equal to 0. So how do you find P of 1? In P of x, P of 1 means what? In P of x, wherever there's x, you should use 1. P of 1, in P of x, wherever there's x, use 1, is equal to 0. And then P of minus 1 is equal to 0, meaning in P of x, wherever there's x, use minus 1 and is equal to 0. Okay. Then, so I've called this equation 1 and equation 2. Add the two equations. Write the equations one below the other and add the two equations. So write the equations one below the other and add the two equations. Plus b minus d. Plus d minus d. So you get 2a plus 2c plus 2e is equal to 0. 2 common. A plus c plus e is equal to 0. So a plus c plus e is equal to 0 by 2, which is 0. Then again write the equations one below the other and subtract the two equations. Let us change the signs of all the terms in the second equation. So now a minus a cancels. C and minus c cancels. These are the new signs, the changed signs. See, this plus becomes minus, minus becomes plus, minus, plus, minus. So what gets cancelled? A minus a cancels. B and B is 2b, you can see here. C and minus c cancels. D and D is plus 2d. Plus d is plus 2d. Then E and minus e gets cancelled. So here you get 2 common. You have 2 common. So b plus d is equal to 0. 2 of b plus d is equal to 0. Then the 2 comes for division. So b plus d is 0. So we proved that a plus c plus e is 0 and b plus d is 0. Like you proved that x is equal to 5 and y is equal to 5. So that means x is equal to y is equal to 5. In the same way, a plus c plus e is 0. B plus D is also 0. That means A plus C plus E is equal to B plus D is equal to 0. Is what? One question. Huh? Which one? Subtracting is or equating? Each one is equal to 0. So you're saying let's equate. Ah. Oh, no. Sorry. Axiom is something which does not have a proof. Axiom, you're saying AXIOM. But why are you bringing that term here, axiom? Amma, that's not an axiom. Axiom has a different meaning and it cannot be used in this context at all. Axiom is a statement which is true, which is universally true, but you don't have you cannot prove it like. It can't be proved, but all of us will believe it's true without any, there's no exception or anything. All of us believe it's true. Believe meaning we know it is true. but it cannot be proved. Such a statement is an axiom. A theorem is a statement that has a proof. Axioms and theorems. Axiom is a statement. A theorem is also a statement. A theorem is a statement which can be proved, where an axiom is a statement which all of us believe is true. All of us know is true. It's a universal fact, but cannot be proved. So, அந்த வேர்டு இங்க வரவே வராது. Axiom and word இங்க வராது. Completed? So what's the procedure? What are we given? What are we given? We are given a biquadratic polynomial and its quadratic factor. A biquadratic polynomial and its quadratic factor. So we factorize the quadratic factor and get the two linear factors, x plus 1. You're behaving like kindergarten children, waiting for your parents to come and take you. They're coming. Okay, so we x square minus 1, we break down and find its linear factors, x plus 1 and x minus 1. So now, you know, x plus 1 is a factor of, we've called this p of x, right? We have called this p of x. So x plus 1 is a factor of p of x and x minus 1 is also a factor of p of x. So equate each factor to 0 and find the value of x. Equate each factor to 0 and find the value of x. X is 1. X is 1. So in p of x, in place of x, when you use 1, the value of this polynomial will be 0. That's what we've written here. P of 1 is equal to 0. The value is 0 because in this place you'll get the remainder. And because it's a factor, the remainder is 0. So now what is P of 1? This is the equation. So how do you expand P of 1? In this polynomial, wherever there is x, you should use 1. And we get this equation. In the same way, when x plus 1 is a factor, x is minus 1. So P of minus 1 is 0. Be very careful. See this simplification. Minus 1 to the power 4 is plus 1. Minus 1 to the power, the minus 1, the whole raised to the power 3. Minus 1. Minus 1 into minus 1 into minus 1 is minus 1. Minus 1 into minus 1 is plus 1. Okay, so all that, and this is the second equation. After this, we need to write the equations one below the other and add and subtract the equations. You can write it in any order. You can, you can perform the operations in any order. You can add the equations and then subtract, or you can subtract first and then add, anything. So what is adding? In the second equation, you should not change the signs. Adding means in the second equation, don't change the signs. So that's adding. So here this gets cancelled. So you get 2a plus 2c plus 2e is equal to 0 plus 0, 0, 2 common. And yeah, you know this, a plus c plus e, because the 2 comes to division here, 0 by 2, 0. So a plus c plus e is equal to 0. And then again write the equations one below the other. Second equation, change the signs throughout. And you see a minus a cancels. And then e and minus e cancels. C and minus C cancels. So we have B plus B 2B and D plus D 2B. Sorry, B plus B 2B and D plus D 2D is equal to 0. 2 common. B plus D is equal to 0. So B plus D is equal to 0 by 2, which is 0. So we've got A plus C plus E is equal to 0. B plus D is equal to 0. Now putting it together, A plus C plus E is equal to B plus D is equal to 0. And that's what we had to do. If you have to prove that x is equal to y is equal to 9, that means what? You must prove that x is equal to 9 and the y is equal to 9. So that means x is equal to y is equal to 9. All right. All right, children. So that's it for today's session. Thank you so much. Good night. And online children, if you've finished writing, you may leave the call. Thank you.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you. Good night. Good night. Good night.